Hello friends, welcome back. In this video we are going to learn about the UML class diagrams, their notations and significance. We will also practice the class diagrams for a banking system, and we will understand how we can construct the class diagram with online tool, that is Visual Paradigm tool. So let's start with a brief introduction of the UML class diagrams. In previous video we learned about the use case diagrams, and we also discussed about the extend, include, dependency and other relationship included with the or can be used with the use case diagram. These terms will also help you to understand the class diagrams in a better way. So here is a definition for the class diagram. So as the class diagram is providing a static view of an application as in the form of objects residing in the system, and it also represents the relationships between them, so different objects and their relationship. So it represents the attributes, classes, functions and relationship to be implemented for the software system. As you can judge by this much of detailed information, you can directly implement, you can directly convert the classes of the class diagram to the implementation, to the code. And here are the benefits of the class diagram. So complex system can be easily represented with the help of object model, as it is always difficult to understand the code, and it is very easy to understand the terms with the help of graphical representation. So complex system can be easily understandable for the developers and the testers and the stakeholders to understand the application. And by this it is also reducing the implementation and maintenance time of the system. Every time you need to upgrade the system, you can refer the class diagrams and you can understand the complex system structure in an easy way. So let's have the look for the notations used for the class diagram. So first of all we have the class. So class is represented with the help of three compartments. Here the class name is at the top of the compartment. So first compartment is class name, and next we have the attributes. Third is operation, means the functions included in the class, and the class members, means attributes and operations are defined with the help of access specifiers. So here the plus is indicating, for any object oriented language the access specifiers plays a significance role. So here the plus is representing the public access specifier. This minus, or we can say that the hyphen, is representing the private access specifier, means it will make the member a private member that cannot be accessible from outside class or from the outside world. So next we have the notation of the hash. Hash is representing the protected access specifier. Okay, so while defining the attributes you must include these notations, plus, minus or hash, depending on your application's requirement. Next we have the association. So like use case diagram, here also we can link classes to each other with a line type, we can say that simple line. So this simple line is known as association. We can also define the roles, means suppose a book is written by author, so you can always label the association, you can always provide roles to the classes, etc. But this line is known as association. Next we have the dependency. So like use case diagram, here also we can define the dependency where one entity is dependent on another entity. So here employee is dependent on employee ID. So this type of relationship is represented with the help of dashed arrow. And next we have the generalization. It is same as the use case diagram. Here the person class is the generalized class, or we can say that abstract base class, and these two classes are the specialization or specialized classes. So a person is can be an engineer, or person can be a clerk. So every person or every specialized class, so this is the specialized class. So every specialized class is going to have all the properties of the person class. So this is the way how generalization works. So if you are going upward, then this is generalization, and if you are specializing the journal class to some specific thing or specific term, then we call it specialization. Okay. So if you want a detailed description of generalization, specialization with example, you can refer the DBMS lecture series where we have a detailed discussions about these entities, relationship, generalization, specialization, etc. And next we have the multiplicity, where you can define the number of entities linked with each other. So here, for example, multiple employees are working for one company. So here the star is representing a relationship of multiple. So multiple objects of employee class are linked with or associated with one company. So here the multiplicity can be 1 to 1, 1 to many, many to 1, or many to many. Like employee working on project. So here we can have a relationship of type many to many, because one employee can work with multiple projects at the same time. Okay, so this totally depend on the requirement of your project. Next we have the aggregation relationship. So it is also same as the use case diagram, where we have the one entity being the part of another entity. So here the employee is part of the company, so it will be represented with the help of this instead of arrowhead you must use this rhombus, empty rhombus symbol to represent the part of. So here employee is part of company, but employee can leave the company and can go to another company. So this is not kind of integral part of the company. So employee is part of company but not integral part. Okay, so this relationship is representing employee is part of company. But if we have a kind of relationship where the one entity is integral part of another entity, in that case we will be having a composition relationship. Means we need to fill this rhombus to represent the composition. So all these notations are representing the term. You need not to define the notations with your diagrams. Okay, so it is understandable to all who are working on projects or who are working on applications, so they know these terms. So composition means if the rhombus, this aggregation rhombus is filled, solid filled, so we call it composition. Here the existence of the page depends on the book. So if the page is part of book, only then page is existing, otherwise page has no existence. So here we can say that page is integral part of book. Without book, page cannot exist. So for this we will be representing a relationship of type composition. I hope you understand the difference between aggregation and composition. So now let's see the example that we are going to implement in today's session. So this is the example of banking system that we are going to work with. So here we have the first class as bank and the second class as branch. So bank can have many branches and these attributes are defined as private members. You can see the sign over here. So these attributes are defined as a private member. You may take the members as protected or public depending on your requirement, and we have defined these operations or functions as the with public specifier with the sign of plus. So these are representing operations. So every class will be representing in these terms. So if you are representing only the class name, like we can have a class diagram without any detail explanation. So bank can be linked with the branch. So this type of class diagrams are not detailed class diagram. They can be said like the simple class diagram. They are not detailed one. Okay, but for implementation you need to define the detailed class diagram and discuss the detailed class diagram with your teams. Next, what type of relationship can exist between bank and branch, and what other classes can be part of the banking system? So apart from these two, we need customer, account and some other classes. So let's see what type of relationship should be between bank and the branch. So as branch can only exist if the bank is existing. Okay, so existence of branch totally depend on the bank. So we can say that branch is an integral part of bank. So it can be represented with the help of composition relationship. So it is represented with the help of composition relationship, and you must be able to find out the type of relationship that you need to define within the class diagram. So here this is the composition relationship between branch and the bank. Next we have two other classes as customer with two attribute name, contact, and two operations, and account as number and account number, and balance of private access specifier, and deposit and withdraw as two operations. So here the customer and account are linked to each other, but they are also the part of branch, means customer is not a bank customer until it is linked or it is associated with some branch. So customer is a part of the branch. Same way account is part of the branch, but customer can have account in some other branch as well, or account can be other branches are also having the we can say that account. So this type of relationship can be existing, means if the customer has left the branch, then the account can be deleted, okay, or deactivated. In that case we can say that customer and account are linked to the branch with aggregate relation. They are not composite relation, because branch will be existing with bank only, okay, but customer can go to other bank. In that case account will be deactivated or deleted. So here the relationship is of type aggregate, okay. And next, customer and account can also be associated to each other. So this is the relationship of customer with branch, and this is the relationship of customer account with branch, okay. Now the customer can also be linked with the account. So there must be some association between the customer and the account, but this time we need to define the limit, means how many entities can be linked to account. So we can say that one customer can have multiple account if the branch allows, but here we are taking a limit of 2. So here every customer can have either 1 or 2 accounts with a particular branch of a bank, okay. And we can also define the label, like with this association we can have customer has, so one customer can have 1 account, or one customer can have 2 accounts with a particular branch. So this relationship is presented like this with the association, and here we are defining the multiplicity from 1 to 1 or 2, okay. And this is the label, we call it the label. So we are labeling the association for the relationship, means what type of association is this. And next is account. So account can be of multiple type. Here the account can be current account or the saving account, but these accounts are also account, okay. Please try to understand. So these accounts are also account. So there is a type of inheritance relationship, or we can call it a generalized relationship between account and these two classes. So these can be taken as the subclasses, and account is your base class or super class. So there is going to be a generalized relationship, because current account is the derived class of account only, means current account must have all the features of account class. Similarly the saving account must have all the features of account class. So there is a type of generalization relationship between these two classes. So after this, let's try to build this class diagram with the online tool that we also used with the use case diagram. So this is the tool that I am going to use. You may practice with any other tool, but I found it really easy to use and flexible. You can create any number of projects with this tool, and it is free of cost for non-commercial use. So let's start. Here I have already signed up. If you have not signed up, you can simply signed up with your Gmail account, and you can simply log into your account. And here are my documents, means I have created these documents. This was the use case diagram that we prepared for the last video. And from dashboard you can select n number of things, but as we are working with diagram, so I am going to take a blank class diagram. So you can also browse for multiple templates, means There are a lot of templates available of the existing class diagram, so you can also take examples from them. And now I am going to create a blank so that we can learn how to create the class, how to define attributes, how to build the relationship, how we can add operations, attributes to the class. Okay, so this is the, we can say, the dashboard where we are going to work. So simply drag and drop the class. So this is our first class. Okay, so let's name the class as bank, as we are working with bank. Next, you cannot simply write in the second compartment. For that you need to add attribute to your class diagram. So here I am adding name, and for next you need to right click and add attribute, and this time I am going to add the code of the bank. Done. Now to add operation, you also need to right click and select the add operation, and this time I am going to add the operation of add a branch, add underscore B. Okay, and to add next operation, this plus remove a branch. Okay, so here we have added the required operations and attribute. You can resize the class rectangle. Now I am simply copying by Ctrl C and Ctrl V, and next I need to create a branch. So let's create the branch first. So branch is renamed. Now for name I need to have branch code B code. Next, the branch must have an address, and for branch we have the two operations like done, manager and manages. So branch is complete. Let's add the customer and the account class to our class diagram. So for this we have, for customer we have the customer name and customer contact, and the name of the class as customer. Done. And for customer we need to authenticate the customer, and customer can also put an inquiry. So functions are complete for the customer. Now we need to add two functions like functions to the deposit, as deposit and withdraw for the account class. So here we have the account class with account number and balance information. And here we have two operations like withdraw and deposit. Withdraw and deposit. Okay, I forgot to add plus for the inquiry, so this must be a public operation. So here we are completed with our classes. Next we can simply copy the class account for the current account and for the saving account. You can also add other variables to account and saving class, like account type. Here the account type must be saving and here the account type must be current. So let's define the relations after this. So like use cases, here we need to drag this arrow, or you can simply drag and drop the relationship from this window. So here I am going to simply drag the arrow to this. So I want the branch to be linked with bank with composite operation. So here we have the relationship with composite symbol. So let's do it once again. So here simply drag the arrow, and from this it will ask for the option, means type of relationship. So here we have selected the composite relationship. Next, the customer is linked with the branch with aggregate operation. Sorry, we need to take the arrow, drag this arrow. So it is linked with the customer with aggregate operation okay. Now branch is also linked with account with aggregate operation. Done. Okay, so here the customer is linked to branch, customer is not linked to account class get. So customer is linked to branch and also account is linked to branch with aggregate operation. Now we need to link customer with the account. So for that you need to put an association, and with association we also want to put some label. So here we are having a label of has, and we can also define the multiplicity like 1. On the left hand side, one customer, one customer can have 1 or 2 account with a branch of a bank. Now we need to add current and saving account classes with account class with generalization relationship, because they are the derived classes of account class. So here we have the generalized relationship. Again, for the saving account we need to select the generalization relationship. Okay, so the class diagram that we learned is complete, and you can add many attribute to your class, many other operations to your class. You must add some other extra features to your current and saving account classes, because they are specialized classes. They must have some extra feature than your account class, but just for the sake of understanding I am keeping it simple. So that's it for this video. In next video we will learn about the interaction diagram with their requirement, specification and notations. So till then, bye and take care.